Welcome everyone. In this video lecture, we will see the change of scale property of Laplace transform. So what is this property? Let's see quickly. If Laplace transform of any function ft is equal to fp, then Laplace transform of f of at will be 1 upon a into Laplace transform of same function ft, and p is replaced by p upon a. We can also write this as 1 upon a f of p upon a. So what is this property? Let us understand. Here we are given this function, and this is a new function where the scale of the variable t has been changed because we have multiplied this variable t by some constant a. This is called change of scale property. So in this new function, the scale of t has been changed. So how to find the Laplace transform of such new function? We can obtain the Laplace transform of this function by just dividing the whole answer by a, where a should be a non-zero real number, and this fp, in this fp, p is replaced by p upon a. So let's see one example to understand this concept. Example is, if Laplace transform of ft is equal to 1 upon p e raised to the power minus 1 upon p, then find Laplace transform of e raised to the power minus t f of 3t. Here in this question, you can see that we have changed the scale of the variable t, as well as this whole function is get multiplied by exponential function. So whenever any function is get multiplied by exponential function, then we have to apply first shifting property. And to find the Laplace transform of f of 3t, we have to use change of scale property. So there will be both property used here. One is change of scale property and another is first shifting property. So it is very simple. Laplace transform of e raised to the power minus t f of 3t. If you remember the first shifting property, it says that if Laplace transform of ft is equal to fp, then Laplace transform of e raised to the power at ft will be f of p minus a. Right? P is replaced by p minus a. Or you can also write this as Laplace transform of ft, and at last p is replaced by p minus a. ये करते हैं. So what we do is, first we apply first shifting property. by using first, you can also apply the change of scale property. The answer will be same. By using first shifting property, we can write Laplace transform of e raised power minus t f of 3t equal to Laplace transform of f of 3t, and in whole answer p is replaced by p plus 1 because of negative sign here. Now we have to find the Laplace transform of f of 3t. So we have Laplace transform of e raised power minus t f of 3t equal to Laplace transform of f of 3t where p is replaced by p plus 1. I have written the same thing as written on the previous page. Now we apply here in this inner bracket, we will apply change of scale property. So by change of scale property, the whole answer will get divided by 3 and L will be applied on Ft, where P is replaced by P upon A, sorry, it is 3, and again there is a whole bracket, outer bracket, where P is replaced by P plus 1. So we have 1 upon 3, and because this is simply Ft Laplace of Ft, and Ft Laplace of Ft is given to us in this question. So we simply put the value of Laplace of Ft, which is 1 upon p e raised power minus 1 upon p, and we replace p by p upon 3 everywhere, and then in this outer bracket, this is equal to 1 upon 3 because p is replaced by p by 3, so this will be 3 upon p e raised power minus 3 upon p, and outer bracket p is replaced by p plus 1, so just cancelled out with this 1 upon p plus 1 e raised power minus 3 upon p plus 1. That's all. This is how we apply first shifting property as well as change of scale property in this problem. Let us do one more example. Example number 2. Let me take very simple example. Find Laplace transform of cos of 4t. This is simply you can apply the formula of Laplace transform of cos of 80, or you can apply the formula of Laplace transform of cos t, and then you can use change of scale property. You can do it in both ways. So if we apply change of scale property here by using change of scale property cos t का लाप्लास ट्रांसफॉर्म, cos t का लाप्लास ट्रांसफॉर्म आपको याद होगा, ये हमने क्लास में किया भी था। cos t का लाप्लास ट्रांसफॉर्म होता है, पहले हम लिखेंगे लाप्लास ट्रांसफॉर्म ऑफ cos of 4t is equal to 1/4 Laplace transform of cos t, and the whole expression p is replaced by p by 4. This is 1/4. This is p upon p square plus 1. I think. And then p is replaced by p by 4. So this is 1/4 p upon 4 p square upon 4 square plus 1. This is equal to p upon 4 square p square plus 4 square upon 4 square is p upon p square plus 4 square. आप इसको डायरेक्ट भी लिख सकते थे by using the formula of Laplace transform of cos at, which is equal to p upon p square plus a square. Similarly, you can do this example also. Let me write the next example for you. If Laplace transform of ft is equal to p square minus p plus 1 whole divided by 2p plus 1 whole square into p minus 1. This is given to us. We have to prove that Laplace transform of f of 2t is p square minus 2p plus 4 whole divided by 4p plus 1 whole square into p minus 2. ये प्रूफ करना है हमें, तो आप इसमें चेंज ऑफ स्केल प्रॉपर्टी यूज कर सकते हैं. It is very simple question. By change of scale property, scale property, Laplace of f of 2t will be 1/2, and it is Laplace of f of t, and p is replaced by p upon 2. So Laplace of ft is given to us in the question. It is very simple problem. Just we have to replace everywhere p by p upon 2, and then we have to simplify. So Let me write f of 2t Laplace of is equal to 1 upon 2 p upon 2 whole square p square upon 2 square minus p upon 2 plus 1 whole divided by 2 p upon 2 plus 1 whole square minus into p upon 2 minus 1. Just simplify this question. Is p square minus 2p plus 4, and here we have whole expression divided by 2 square. This 2 will cancel with this p plus 1 whole square, p minus 2, and this 2 and this 2 will get multiplied, so that this we have to p square minus 2p plus 4 plus 1 whole square into p minus 2 so there is one 4 is extra here, I think. Yes, this 2 will come here in the denominator, and this 2 will go upwards. This will not be square here. Let me make correction here. This is the denominator 2 will get multiplied with this expression, and this 2 will remains as it is, so that they will cancel each other, and this 4 will come in the denominator. So that's a matter of just simplifying the expression, nothing at all. So this is how we can use change of scale property while doing the problems related to Laplace transform. So if you have understood the lecture, you can press the like button and share my lecture also. You can also subscribe my channel to get the notification of any new video on this topic. Thank you very much.